Okay, last example here. So we're going to use point A, B, C, and D with the coordinate points 2, 0, 0, 8, negative 4, 7, and negative 2, 1, respectively. We're going to first try to show that segment AC and segment BD bisect each other. Then we're going to try to show that segment AC is equal in length to segment BD. And then we're going to then try to identify what type of figure shape is this polygon ABCD, right? So start with part A, just showing that they bisect each other. So we're looking at two segments, see if they bisect each other. If they bisect each other, then that means the midpoint of segment AC will have to be identical to the midpoint of segment BC. So let's start with that, right? So they're going to have the same midpoint. So I went and labeled points A, B, C, D here in red. I sketched the line segments in for AC and BD. So we're going to look at, if these two segments, blue and green here, actually bisect each other at this point right here, this point should be the same as the midpoint of both of these segments if they do in fact bisect each other. So let's use the midpoint formula. So we're going to work with AC first, and we're going to just, take the average of the x coordinate and then the y coordinate, right? So 2 plus negative 4 for x divided by 2, 0 plus 7 for y divided by 2. That leaves us with the coordinate midpoint negative 1 comma 7 halves. Now we're going to work with segment BD here in blue, same concept. So for the x coordinate of both B and D, it's 0 plus negative 2 divided by 2. And for the y coordinate of segment BD is the a plus negative 1 divided by 2, leaving us with negative 1 comma 7 halves as the midpoint. Since both midpoints are the same, then we can conclude that segment AC and BD bisect each other. Next up for part B, we're looking at, show that segment AC is equal to BD. All right, so if that's the case, then the distance, the length of segment AC and segment BD, should be the same. So now I'm going to use the distance formula. So negative 4 minus 2 squared plus 7 minus 0 squared. It's 36 plus 49, which gives us square root 85 units, right? So you can approximate this. I'm going to leave it as is just because I'm just comparing it to the length of segment BD now, right? Same process, BD, negative 2 minus 0 squared plus negative 1 minus 8 squared. That gives us 4 plus 81, square root 85 again, units. So therefore we can conclude that length AC, the length of segment AC is equal to the length of segment BD. Satisfying the second part of our question. What kind of figure is ABCD, right? So we can connect the sides of this polygon right here, and it's going to look like a parallelogram. But in fact, it'll actually look more like a rectangle, right? So one of the things we probably forget from geometry is, a rectangle is a parallelogram, first of all. And some of those characteristics of that parallelogram of the rectangle is kind of like under the umbrella of parallelograms, is that the diagonals, so in this case BD and AC here, they are congruent and they bisect each other, right? So therefore we have a rectangle named ABCD.